So good afternoon, everyone. In this video, we are going to discuss about set operations. So these are a few set operations that we can make use of: the set union, set intersection, set difference, and set complement. And we will start discussing set union. So to denote the union of two sets, we use this U-shaped na symbol. And taking the union of two sets, what we essentially mean is combining the elements of two sets into one set. Okay, so we are taking elements that are either in A, in B, or both A and B. So formally, for sets A and B, their union A and B is the set containing all elements that are either in A or in B, or of course both A and B. So formally, we can express it using a set builder notation form that for all A and B, the union of A and B is a set of all elements X such that X is either in A or X is in B. So from the definition of conjunction and or, so we are essentially taking elements that are either in A, in B, or both. Okay, so note that A union B contains all the elements of A, and it contains all elements of B. So therefore, we can say that for all A and B, the union of A and B will be a superset to A, and A union B is also a superset to B. So what we are essentially saying here is that A is simply just a subset of A union B, and B is also just a subset of A union B. All right, so now we have these examples. Taking the union of these two sets, A, B, C, and 2, 3. So the result would be a set containing A, B, C, and 2, 3. Now, taking the union of this set containing 2, 3, 5, and the other set 3, 5, 7. Now, let us combine it in only one set. So it will result to 2, 3, 5 from the first set and 3, 5, 7 from the second set. Now, the definition of, or a property of set is it has distinct elements, okay? Or we should remove the duplicates. So this will be the required form 2, 3, 5, 7. Okay, now we have removed the duplicates for 3 and 5. Okay, so picturing it out in a Venn diagram, we have a set A, which contains 2, 3, and 5, and the set B, which contains 3, 5, 7. So 3 and 5 are elements that are present in both two sets. So taking the union of this, we are going to take the elements from this set, as well as the elements that are in both sets. So it will be 2, 3, 5, and 7. Okay, so here are some properties of the union operation. So kindly disregard the image below. So we have the A union empty set. So it will be equivalent to A. So this is what we call as the identity law. So suppose we have a set A, right? And we are going to combine it with an empty set. So taking the union, we are going to take the elements in A or the elements in the empty set and both A and the empty set. But we know that the empty set has 0 elements. Okay, so it will be the resulting set will then be just elements from A. Okay, so it will result to A. Now, A union, the universal set, is the universal set. And this is what we call as the domination law. So we have this set A, going back, we have this set A, and then taking the union with the universal set. So it will result to a set or the universal set. So we are essentially combining elements from A and the elements from the universal set. So we then have the universal na set. Now, we also have the idempotent na law wherein A union A will result to A. So taking the elements from A and also the elements from itself. So combining this into one set. So now, since we are going to, the sets have no duplicates or have distinct elements, so it will still end up having just the A, okay? Now, the A union B is also equal to the B union A. So this is the commutative na law. And then A union of the quantity B union C is also equal to A union B union C. So this is, on the other hand, is the associative na law. So suppose we have this sets A having elements 1, 2, 3, and B having elements 2, 3, and 4. So what would be the A union B, and what would be the cardinality of A union B? So we have a set A, 1, 2, 3. So the cardinality of A is 3. The cardinality of B is also 3, since B has also 3 elements. So the cardinality of A union B is 4. So why is it 4? So we are essentially taking the element from A, the element from B, and subtracting the elements, that the number of elements that are in both A and B. So this is the principle of inclusion, exclusion, right? So we have what is the cardinality of A? 3. Cardinality of B, 3. So 3 plus 3, that will be 6. So minus the elements that are both in A and B. So what are the number of elements that are in A and B? So that is the 2 and 3, right? So we have 2 elements that are both in the set. So 6 minus 4, minus 2, I mean, so that will give us 4. So the cardinality of A union B is 4. Now let us move on to the set intersection. So the set intersection is denoted by this symbol that simply flip vertically the U-shaped symbol, so we get the intersection. And the intersection is simply the elements that are both in A and B. Okay, so for sets A and B, their intersection A and B is the set containing all elements that are simultaneously or both in A and in B. So formally, for all A and B, the intersection of A and B is a set of all X such that X is in A and X is also in B. Okay, so if X is not in A, then it will immediately result to false. Okay, so we only want those elements that are both in A and B. So note that A intersection B is a subset of A and B, and it is a subset of B. So for all A and B, the A intersection B will then be a subset of A, and the A intersection B is also a subset of B. Okay. So in other words, the intersection would then be contained in A, or every element in the intersection will be in A, and every element in the intersection will also be in B. Right? Now let's have this examples. Suppose taking the intersection of these two sets having elements A, B, C, and 2, 3. So, and then we also have another item here, taking the intersection of 2, 4, 6, and 3, 4, 5. So this first na item will result to an empty set. Why is that? Because there are no common elements between the two sets. Okay. The other set would yield to a set containing a 4 element na 4. Why? Because it's the only element that is common in both of the sets. Now, suppose we take the intersection of a set with an empty set. So this will result to an empty set because any set intersection with the empty set yields the empty set. So anyway, just going back to this previous example, we have the set 2, 4, 6 and the set 3, 4, 5, and the intersection between the two sets is only 4. Okay. Now, these are some properties of the intersection operation. We have the A intersection. The universal na set would be equivalent or yield to A. Okay, so this is the identity law. So as you can see here, we have a universal na set and we have a set A. And what would be elements that are common in both A and the universal set? So that would be the A. So this is equivalent or will yield to A. Now, taking the intersection between the set A and an empty set would yield to an empty set. So this is the domination law. So suppose we have a set A having these elements and an empty set having 0 elements. So now what are the common elements between the two? There is nothing, right? So this will yield to an empty set. Now, the intersection of a set with itself or A intersection A will also yield to A. So what are elements that are common in these two sets having the same elements? So this will essentially yield to elements that is in A also. So this will result to A. Now, we also have the commutative law, and it also applies to the intersection operator. So we have the A intersection B, it will be equal to B intersection A. So we simply interchange the position of A and B. And then the associative law will also apply to the intersection operator. So we have the A intersection B intersection C. It will be equal to A intersection B intersection C. And we also have the disjoint set. And what is it? So let us see. Suppose we have this example. Taking the intersection of its two sets, this will yield to 2 because it's the only common element between the two sets, right? So what if we have this example? We have a set such that it contains all elements x such that x is an integer or belongs to the set of integers and x is odd, intersection z or intersection z, which refers to the set of integers. So this will basically yield to itself. So what law does it use? So it uses the identity na law. Okay, so this will result to itself for a set of x such that x is in z and x is odd. Now we have a set x such that x is an integer and x is even and x such that x is in z and x is in odd. So this will result to an empty set. So we are essentially taking the intersection between a set of even numbers and a set of odd numbers. So since there is no number that will be both even and odd, so this will result to an empty set. So what law does it use? So it uses the domination law. Okay. No. So this uses the this is essentially a disjoint na set. I mean, since this two sets does not have a common elements. And we call two sets to be disjoint if their intersection is empty. So here is how we can picture a disjoint set. We have a set A and another set B, and there is no common element between the two sets. Okay, so here are some more examples. So we have a set 1, 2, 3, a set containing elements 1, 2, 3, and a set containing elements 3, 4, 5. So it is not disjoint because we have a common element 3, and then we have another set here, New York and Washington, in a set containing 3, 4. So this will be disjoint, no common between the two. And a set containing 1, 2, and an empty set will also result to disjoint. Okay, and then an empty set and an empty set will also be, it will result to a disjoint. Now,